So welcome to another Inform session. My name is Elias Bieskas. I mean, this is for those of you who don't know me. I know there's a lot of new names on the participants window here. So I'm a technical partner manager at NetApp, and I'll be one of your hosts today with Mary Jo. We deliver an Inform session every month, and you will receive an invitation every month. We do record these sessions, as Mary Jo mentioned at the beginning, and we'll also send you the link and also the presentation. So today's topic is Veeam backup solution for HCI, and presenting we have Rizwan Ahmed and Victor Ifediora. So Rizwan and Victor, can you present yourself and tell us what you do at NetApp? Also, please start whenever you're ready.
Okay, so everyone on the call, this is Mary Jo. I want to let you know that we've pre-recorded this presentation. Rizwan is out of our Bangalore, India office, and he's had some internet instability issues. So just to be safe today, we pre-recorded. So we're going to play this in 4 sections, but we have Q&A sections embedded in it. We'll stop at that point, take your questions. Feel free to put your questions into the chat window. Feel free to ask them at this Q&A designated points. But it will be, it is pre-recorded just because we wanted to ensure that that Rizwan had a good internet connection when he presented. So this is a bit of an experiment, and so we appreciate your patience. I'm going to try my best not to mess it up. So with that said, we're going to go ahead and start. Rizwan's going to do the first 3 sections, and then Victor will do the last one.
Go ahead, guys.
Hello, everyone. Let's have a quick overview of today's agenda. First of all, we are going to talk about why we choose Veeam solution, followed by architecture diagram, S3 storage grid, Veeam backup process overview, Veeam storage backend infrastructure, and then we do have storage backend infrastructure, which covers E-Series storage for Veeam repository. Now let's move on to why we choose Veeam. So Veeam is a backup solution like other vendors. Veeam also provides a backup solution which can perform backup, restore, replication. Along with that, there are additional features such as application-aware backups for critical apps such as Active Directory, SQL, and MS Exchange. So Veeam is a partner solution for NetApp HCI. Veeam, again, it's a solution which can integrate with all our NetApp products such as StorageGRID, ElementOS, HCI, E-Series, and ONTAP. So it's an image and file level backup it supports, and it's agentless, and it's very easy to manage and administer. We don't need a storage administrator to configure or install and manage the entire Veeam backup infrastructure solution. So it also has like granular backup restore solution, which makes it easy for all the administrator who can easily handle it. And it reduces the complexity of all your backup infrastructure with the way of source side compression and the deduplication. It has got more capabilities than your native backup solution. So when we talk about compression, so we get, by default, we get the optimal compression with the LZ4 format, which also provides us a 2:1 ratio of compression. So it is fairly light CPU overhead on all your infrastructure components, which gives excellent throughput with the rate of 150 Mbps per second per core for your backup, as well as even we get a faster decompression rates. And also we do have the deduplication, which reduces the amount of data that has to be stored on your disk by detecting redundant data within the backup and storing it only in once rather than like multiple blocks. So Veeam deduplication is based on identifying the duplicate blocks inside a single VM disk or across multiple VMs inside the same job. So we have all these good features, which gives us a value for having a backup infrastructure for a HCI. And along with this, NetApp HCI, we don't have like certified inbuilt native solutions from NetApp. So as a partner solution, we have chosen Veeam for our backup infrastructure. So at the moment, we do have deployed Veeam backup solution in 2 US data centers within HCI infrastructure, which is serving 1,400 VMs backups. Now let us review our architecture diagram. So we have like core components from Veeam backup setup, so which serves all your backup jobs. So which provides a backup infrastructure to your HCI infrastructure. So when we talk about 2 data centers, there are 2 data centers in our US, which is one for production and another one is for subprod. So let me talk about production subprod data center. So we do have HCI infrastructure, which is hosting all your virtualization environment, and which is using the SolidFire as your storage, backend storage. And on top of SolidFire storage, you have the hypervisor, which is serving VM workloads. So now like to get this backup, we have configured Veeam backup infrastructure using some of the components. We got a license for enterprise license, which covers backup manager, enterprise manager console, along with that Veeam repository, and we can also expand to a StorageGRID, like using a scale-out repository. All these are covered within our license. So we do have some additional components which we are not using at the moment today. So let us talk about individual components. So we have Veeam Backup Manager. That's a software. It's installed on the Windows machine. So basically, it's a configuration or control center which maintains all your scheduled backup jobs, and it controls all your tasks, what it has to be run, like for which VM, and what are the types of proxies you got, what backups you're running, how many VMs, everything is controlled from your backup manager. And it maintains the database within your DB. That also we have used the SQL DB, and within that entire configuration database is managed. And then next, coming to the proxy is like, it's again a architecture component that sits between the backup server and other components of your infrastructure. So proxy server, right? Like when you talk about backup manager, it administrates all your tasks. It controls all your tasks. When it comes to proxy, it processes all your jobs and it delivers backup traffic to the rest of the infrastructure components, such as backup repository, which is needed for storing all your data. So now let us move on to storage repositories, right? Backup repository. So on the backend, we are using E-Series storage for all our infrastructure backup copies. So now let us talk about backup repository. Once again, this is installed on your Windows server. So we are using Windows 2016 for all backup infrastructure components, and we are purely installed on Windows base. We can even definitely use Linux operating system for the repository, but backup manager and SQL, that's a core again requirement on which has to be installed on the Windows server. Now repository, that's a storage location where Veeam keeps backup files, VM copies, and metadata of all your replicated VMs are placed. So metadata, when we talk about metadata, when you're trying to replicate your backups to remote locations, so obviously you should maintain the metadata. That will be stored in your primary repositories, so which maintained by Veeam repository server. Now, let us move on to the additional components. So we do have the additional components such as Veeam 1, which we are not using in our infrastructure, since we do have additional monitoring parameters, like we do have Xenos or Splunk or like other tools which can integrate or like with entire Veeam solutions. Veeam also provides REST APIs which can be used within your infrastructure depending on your needs. So now like that's the reason like we have not been using Veeam 1, which serves monitoring and end-to-end analysis purpose. within Veeam backup infrastructure. Instead, like now, like we are using Veeam Enterprise Manager that serves as a single interface where you can manage or control all your jobs. It's a single pane of glass where you can see multiple backup infrastructure setups. And along with this, we do have the scale out repositories. Like we talked about the S3 StorageGRID. So that's like a scale out repository. Scale out repository, it's kind of extending your repositories depending on your growth needs. So today you have a repository of 30 TB from the E-Series. If you want to grow more, you don't need to go for again E-Series. Instead, like you can use scale out repository to extend your existing repository, adding as an extent. The scale out repository is a logical entity. It groups several backup repositories called extents. When you configure the scale-out backup repository, you actually create a pool of storage devices and system summarizing their capacity. For long-term storage, you can use the backup replication to offload the extents to the cloud. So you're basically like keeping your offline backups within other storage rather than keeping it on your primary storage infrastructure. So we are going to offload the extents to the cloud. Now, expanding the scale out backup repository, like we can expand our scale out repositories depending on growth at any time. We don't need, like we should be doing it when it's reaching the capacity, or like even without reaching capacity, you can extend or like even shrink the capacity depending on your needs. So S3 StorageGRID provides a capacity tier for your entire backup infrastructure. So which gives like a better value for your overall backup infrastructure. So let me stop here and we'll take some question and answer if there are any.
All right, are there any questions at this point in time? We have both Rizwan and Victor on the call. So if there's any questions, we can also go back at this point if you like and look at any slides in detail. Questions? Please feel free to use the chat window, then everyone can see your questions as well. There are some questions. Can you use the StorageGRID directly, or does it need to hop to a repository?
Yeah, we can directly connect to a StorageGRID, like adding as an object storage. So instead of like having a E-Series storage, we can easily point to an object storage. We can have it.
Okay.
That's related to the StorageGRID question. And is there a plugin for the HCI storage? So it's nothing for a HCI storage specific, but yeah, you got a plugin for a vSphere.
And do we have a lab on demand to practice? I assume so. I don't know for sure. I'm happy to take that as an action unless Elias, do you know?
Sorry, Mary Jo, I was looking at who was on mute, but what was the question?
Lab on demand. Do you know if there's a lab on demand available to practice?
On Veeam. I think there is one. I'll check now and I'll reply back on the chat.
Okay. All right. All right. Let's, I have to find out where I'm at, guys. All right. So we're going to, let's go back here. We're going to start again on the second part. Again, for everyone on the call, it's a little clunky, I understand, but these were pre-recorded to avoid some internet issues with. So let's go on to the second part. Let me do this again.
Now we are going to talk about Veeam backup process overview. So in the previous slides, we discussed about the architecture diagram and some of its core components. In this slide, I'm going to discuss about the core components of your Veeam infrastructure, how it is going to integrate with your HCI infrastructure to manage all your backup solutions. So as we discussed about HCI, like in the backend, we are using SolidFire for a storage, which serves all your ESX data store And then from data source, we have all the VMDKs, OS VMDKs running through SolidFire. So now let us discuss about Veeam core components again, how in detail how exactly it works, the backup flow. It happens from backup manager to backup proxy and how it interacts with vCenter to manage your backups, and again how exactly it transmits to the repository servers and what are the action items it does. So when we talk about the backup jobs, so earlier we discussed about the core components Veeam Backup Manager, right? That's like your controller, which manage or administer all your jobs. So when your new backup job session starts, Veeam Backup Manager reads all your job settings from the configuration database and creates a list of VM tasks to process. For every disk of VMs added to the job, Veeam Backup and Replication creates a new task for each VMs. So it's an individual task again, like it creates, even though it's your job is having multiple VMs for individual VMs, and again within the VM, it treats each disk as another task. So once it creates a task, Veeam Backup Manager connects to the Veeam Backup Service, which is installed on your backup manager server, which is Windows-based server. The Veeam Backup Service includes a resource scheduling component that manages all your tasks and resources in the backup infrastructure. The resource scheduler checks the backup infrastructure, resources are available, and it assigns the proxy. So by default within your job, right, when you create a job, you will assign the proxies and the repositories. So for processing any task, these are the mandatory things which you should have, or like before scheduling your job, you should have the repository and then the proxy server, which interact with multiple like your layers, and then get the backup copies. So once you have these backup proxies and the backup repositories to process your task, Veeam Backup Manager connects to the Veeam Transport Service on the target repository and backup proxy servers. So it interacts between these two components, and then the Veeam Transport Service starts the Veeam data movers on both the sides, one on the backup proxy and on another one on the backup repository. So you get a data movers which source and the destination which coordinates each other with the data sets. So a new instance of data mover is started for every task that the backup proxy is processing. So Veeam Backup Manager queries information about VMs and virtualization hosts from your broker service, which is again, like we call it a source side Veeam agent, right? So once it gets the list of your VMs and the virtualization host, it collects all the information, how much the source side data it is needed, and again on the repository, it evaluates the data space is available to back up it or not. Once all this information validation is done, if the application aware image processing is enabled, like we talked about in the architecture diagram, if you have the application aware backups, you can easily get the application level restoration task for such as application Active Directory, SQL, or even Exchange. So you can restore your any user objects within Active Directory. If you deleted by mistake any user content, that also you can restore it, application aware backups. So if you have that processing is enabled on your jobs, Veeam Backup Replication connects to the VM guest OS operating systems. It deploys the runtime process on VM guest OS. Once you have the runtime process, it performs in-guest processing tasks to evaluate what is happening or what is running to take the backup content. If you don't have it, it processes the job. So only like it works when you are using application aware backups. So Veeam Backup and Replication request to the vCenter to create a VM snapshot. So it uses the vSphere technology to get the data in terms of a snapshot. So when you initiate that task, VM snapshot task, VM disks are put into the read-only state. And every virtual disk receives a delta file, and all the changes that user makes to the VM during the backup are written to the delta files. So now like what happens, the source VM data mover reads the VM data from the read-only VM disk and transfer the data to the backup repository in one of the transfer mode. During the incremental job sessions, the source VM data mover uses the change block tracking method. So this is really needed, right? Like when you're doing an incremental job, so what was your previous state and what are the changes has been done with the current backup? So to retrieve those data records, it uses VM data mover uses the CBT, we call it a CBT, change block tracking, to retrieve only those data blocks that have changed since the previous job session. If the change block tracking is not available, so if you're taking a full backup, if you don't have anything, right? So, and there's nothing is modified, then obviously like it just goes with a blank sessions, right? There's no changes happen and it just updates the metadata file. So if there are any modification is done, it tracks those, whatever the change happened, right? Change block tracking, it captures those information and it updates your backup repository metadata file. So if the change block tracking is not available, the source VM data mover interacts with your target VM data mover on the backup repository to obtain the backup metadata and uses this metadata to detect blocks that have changed since your previous job sessions. So it all depends on what sort of backup you're running, whether it's full backup or incremental backup. If it is an incremental backup, it tries to evaluate your block, so whatever it is modified in the previous backup, only those things it gets tracked. So while transporting the VM data from the source, Veeam data mover performs additional processing again. So it filters your zero data blocks. So we talked about the deduplication. So again, like deduplication, it evaluates your zero data blocks and block of swap files, and it excludes all the VM guest OS files. So the source VM data mover compresses VM data and transfer it to the target VM data mover. After the backup proxy finishes reading all your VM data, still we are talking about the backup proxy, all the processing is happening. So because VM backup manager, it controls your task and then it's passed on to your proxy, right? Proxy is like trying to interact between your repository and the vCenter infrastructure to read all the processing tasks, right? So now like once you have the information, it got the data from the source side by even compressing the data and it transferred to the Veeam data mover. So after backup proxy finishes all your reading the data, Veeam backup replication requests the vCenter server to commit the VM snapshot. Till now it did not commit the snapshot and we had the read-only image, right? So now the data delta file will be deleted and it will be committed and VM will run through a normal application. So with this, we are using the deduplication, right? It removes the zero blocks, block files of your swap files and blocks of excluded VM guest files. So with this, we are able to save a lot of data. And then finally, it moves to your repository. So it depends on your type of job. If you are doing a full backup, the repository will get a VBK file, and if you're using an incremental job, we are going to get an incremental WIF file. And in case of application aware, again your SQL or log backup will get a VLB. So with that, right, like entire process is driven from source to a destination repositories. I hope like you guys have understood like the entire process, how it works. So let me, since we don't have a demo session for this webinar, I'm going to take some of the slides, how exactly it looks within this backup jobs, right? When you're creating a scheduled backup jobs, how does it look? Let me just go through the next slide. I'm going to create a view, show you a sample job view. So when we are scheduling a sample, any backup jobs, right? We definitely need to provide a proxy selection. And before that, like you need to select the virtual machines, how many virtual machines you're choosing. Once you have the virtual machines content, you can choose your proxies and the repository. So you can even see like how much space is available within your repository and how much restoration points you're going to keep. So if you're trying to like a daily one snaps, if we're retaining it for 30 days, so you can specify the restoration points at 30. And also like whether you're doing an incremental or reverse incremental, and if you're using any full backup. So in our case, I give an example, right? Like we are using incremental on a daily, and every Saturday we are running a full backup. And we talked about the process, right? So when we initiate a backup job, it evaluates all your VMs and it gathers how many disks are running on each VM. So it evaluates the size of your data, how much size for each VM it has. So suppose I have extracted a snapshot for 5 VMs, we executed a job. So the overall VM size is 851 GB. Out of that, like it tried utilizing the CBT, change block tracking is enabled on this job. So it utilizes CBT to validate what are the contents is modified. So obviously it has got the 246 GB out of 851 GB allocated space, and then it started processing the backups. So, and again, we talked about it evaluates your even the network throttle, how much it is from the proxy or which layer you have a bottleneck. It evaluates all these things and then it processes your job. So if you look at a single VM, what exactly happened? So the backup infrastructure resource have assigned. Once it is assigned a proxy on repository, it start processing for individual VM, which is a size of 77 in our case. In example, what I have selected, and it went to the VMware and it collected a snapshot for all the VMDKs, and then if you have a multiple hard disk, it will go to the multiple hard disk and then take a snapshot. And then it start processing your CBT, like what are the changes happen, and it tried to remove this block files, like 0 block files or swap file or guest OS. Once everything is done, the data gets processed and it gets creates an image. After creating an image, it removes a swap delta file within your vCenter. So once everything is processed from the vCenter to your backup infrastructure, the backup job gets executed and the data file moved to the repository. So that's an overall view, how exactly it works. And we can see in the results also. So in terms of backup execution, so it did evaluate your size. So when we started, our VM capacity was 851 GB, and the data modification, data read, it was around 184 GB. But out of this, like the data transferred is 114 GB. So the overall capacity of your backup size was 120.9 GB, but the deduplication, it was 4.7x, and also we got a 1.5x compression. So it removed all 0 blocks successfully, and then we were able to achieve a better backup. So this was for a full backup. When you compare to incremental backup, it's even lesser. The modification was very less. Since the data changes was very less, we got a backup size of 5.5 GB. So let us move on to repositories. When we talk about repositories, so within our infrastructure, we got multiple repositories from E-Series to manage almost like our 1,400 plus VMs, right? So each repository we have selected 30 TB of size. So keeping multiple repositories is a beneficial. We'll talk more about this, why it is beneficial. So when you're running a multiple jobs, obviously like you can run multiple jobs at a time. You don't need to have a single job with a for multiple VMs. You can split the VMs and run through multiple jobs. So in that case, you can use multiple repositories and you can write onto the multiple storage locations. And also it gives a better visibility for you in case of any growth point of view. If you need if you're reaching the limit of your backup repository, you can use scale out repository. That also we'll discuss. So if you reach that limit, you can extend your backup repositories. So as we spoke earlier, in our case, we are using incremental backup once and active full backup on every Sunday. So I have also illustrated some of the backup time, like execution times we have achieved within, it's an average time. So suppose you can see like we had the VM count of 114, which was utilizing 7.43 TB, and the active full was 4.5 minutes, but incrementally it took only 50 minutes. But at the same time, there's one more highlighted, it's same size, total size of VM capacity was 7.76 TB, but the VMs count was 73. But it did took a lot of time because the IO was written too much. We do have OCI or like OUM applications which are evaluating the entire infrastructure, right? Like it is writing every now and then, it is writing the contents on the disk. So that's the reason we do see like there is a huge difference between similar jobs with a similar capacity, but the data size is high. So let me stop here and we'll see if there are any questions, and we'll try to address that.
All right, we do have questions. We have lots of questions. Let's go back up here to the chat window. Can you all see? Okay. Oh, okay. So going back to the question on Lab on Demand to practice, there are 3 Veeam labs in Lab on Demand. There's a URL there for everyone. I don't know if you can see my chat window. Is this application aware like Exchange? Yes. Or only Veeam? I guess maybe I should, oh, sorry, Rizwan, you answered it. Thank you. Yes, application aware you can use for SQL, Active Directory, and even Exchange. But NetApp we are just using for VM backup. We're not using application aware backup. Element plugin for Veeam version 10. There's a URL there. What does the plugin do? Enabling hardware snapshots. Yes, the answer is. And there's one last question. When will VSC or SnapCenter be available for HCI? I'm not sure if anyone on the call knows the answer to that.
Yeah, we don't know the answer for that. We'll have to follow.
Okay.
I will follow up with Gavin. That's okay.
Okay. Are there any other questions? We're happy to go back again to any slides if you want to look at something in detail. All right, let's go on to part 3 then.
Now let's talk about challenges observed. In the previous slides, we discussed about the overall backup process weave, and now in this slide, we are going to discuss about the challenges. What are the challenges we have observed, like while implementing overall backup infrastructure for our HCI on both data centers? So the first thing is we talk about snapshot. So Veeam is utilizing your snapshot technology from the vCenter, right? VMware snapshots to create your backups. So in that case, you shouldn't have like VMs having already a snapshot. that creates a problem. Like you will not be able to execute a backup, which is already VM is having a snapshot. And the second limitations. So Veeam is maintaining a limitation per backup jobs. There are certain VMs can have like 200 VMs as a capacity, we can say. It's more than 200 VMs, it will not allow you to create backup jobs. The third one, we talked about VM tagging. So Veeam always recommends you to use the tagging method. Within vCenter, you can tag all your VM with an application code. So it helps in multiple ways. So when you're managing your infrastructure with a VM's tagging, you can backup your VMs using tagged. So XYZ, I can take an example. I have an XYZ application. I'm grouping all my XYZ applications with the tag code XYZ. So if I need to backup those application VMs, I simply go to Veeam and create a backup job with a tagged identity as XYZ. So by default, it pulls all the VMs within that XYZ tag and it evaluates the size. So this is like kind of a requirement to have a backup for all your newly provisioned VMs. So you're adding new VMs with again XYZ. You don't need to come to a backup job and then again modify your list of VMs. You don't need to do that. Since you use the XYZ, it automatically adds your VMs to the XYZ job. And again, while deprovisioning, you don't need to come here to modify the content. So it takes care of it. And the last point I talk about proxy VMs. Proxy VMs should not be part of same backup jobs. So in the previous slides, we talked about proxy selection. When you create your backup job, you need to define which proxy you're going to select. So suppose you have multiple proxies and you're trying to choose out of 2 or 3, like you're going to specify a single repository like proxy. In that case, the same proxy server should not be part of that like backup list. So what happens is like proxy is your processing unit, right? So you're trying to create a job backup for your proxy server with the same proxy, so which is not allowed. So that's the reason like we always recommend to go with automatic selection. So with automatic selection, there are multiple options you're going to get, or like a better performance, because processing speed you're going to get more. And by default, Veeam try to evaluate which proxy is free, and it will allocate from the automatic selection. So these are the challenges as observed. So you can take care of it by configuring it appropriately. So now let us talk about single or best practices, whether having single or multiple repositories, or single or multiple proxies, or multiple job schedulers. So let us talk about multiple or single repositories. So it all depends on your infrastructure setup. If it is a very small setup, you don't need if you have a like less than 100 or 200 VMs, then obviously you can have a single job with single repository, and also you can use single proxy. So you can't have like for a single job, you can't have multiple repositories. So you need to run through your backup on a single platform only. So if you have a bigger infrastructure like enterprise-wide architecture, in that case, you should always have like multiple repositories and multiple proxies for getting a better processing speed, or you can increase the processing speed with your multiple proxies. And multiple job schedulers. So obviously you can run multiple jobs at a time. So yeah, that gives like a flexibility, right? Like you're going to get a more performance with the multiple job schedulers. And also proxy VMs should not be part of the same backup jobs, which we already discussed. So that's a best practice. You can avoid it. Like you go for an automatic selection, and even job schedulers, when you're using multiple jobs, try to select multiple proxies and use repositories in a proper way. You can construct your entire backup infrastructure. So I will give you a simulator. So from Veeam itself, we get the simulator, Veeam Restore Point Simulator. You can use this tool to evaluate, or you can construct your backup needs by providing your growth rate, or what's your utilization, and what exactly you need as part of your restoration points, right? So suppose you're looking for 30 days or like 14 days, depends on your retention points. You can evaluate the space needed for running your backups. So in this example itself, you can see, right, like I have taken 1000 GB of overall our data store capacity, and the retention now what I'm looking for is 14 days, and change rate, how much change rate you're looking around. So at the moment, like for this restoration point simulator, we choose 10%, but in some cases, like we do have VMs, right, like the OCI and OUM VMs. So in that case, like the change rate is almost like 90%. So you can see that it changes on very often, right? So it depends on your infrastructure needs. You can set these parameters, and also like overall growth, how much you're looking. So for per year, is it 10% or 20%? So you can decide your requirement, and then you can get the results, like how much you need overall space for your repository. So this tool is a good feature from Veeam. So we don't need to again wait for your storage administrator like to validate and come back with the capacity requirements. Instead, you can yourself, you can define what is your needs and how much copies you're going to maintain, what are the various backup options you're going to use, whether it's a synthetic or active full or incremental. These kind of things you can do yourself, and you get capacity requirements needed for your repository in a better way. So with that, I'm going to move on to next slide, where we are looking for some enhancement from Veeam. So this is already placed. This requirements has been placed with Veeam, and we are still awaiting for their future releases. We'll see like how it goes. But let me talk about what are those enhancement requests. So cluster level backup jobs. So cluster level backup jobs will address all our new provisioning, or like individually you don't need to add new VMs, or you don't need to create a backup jobs, right? It can automatically, once you have a cluster level backups, it can trigger automated backup jobs. Depending on the need, even though there is a limitation, it can create a number of backup jobs. So that's a feature we are looking for. And again, the VM limitations for backup jobs, that also like we are looking around like why there is a limit. So they should either give it in an automated way so that we don't need to worry about the limitations. It can automatically create by its own. So again, the third point we talked about VM tagging. So VM tagging, suppose again we talked about XYZ application. It has a 180 VMs. Think about this, 180 VMs as on today, and you're using the XYZ tagging for creating your backup job. So what happens again, tomorrow you're adding another 30 plus VMs. So does it create an automated backup job, or you have to manually do it? So as on today, like we need to create the backup job manually. So this is the kind of requirement, like it stops you, right? You got a automated feature with VM tagging, but again, it's not 100% successful since like you hit the limitations. So to overcome this, we need to have a solution. So we have requested Veeam for enhancements. So let us see how they come up with future enhancement on these things. So with that, I'm going to stop here. We'll take some questions, and post to which Victor is going to talk about storage topics, storage and its backup Veeam backend infrastructure components. So let me stop here.
All right. right, we're at a stopping point again for questions. Are there any questions? I don't see anything in the chat window right now. Questions?
There's no questions, Mary Jo. Victor can carry on. That's fine.
All right, let's go.
Thank you.
Good morning, good afternoon, and good evening. My name is Victor Ifediora. I'm going to be presenting the storage backend that is used for this Veeam backup solution for our HCI.
Oops.
The storage platform that we are using for this solution is the E-Series, and the model of E-Series is the 5700 and E5760, that comes with 60 drives. We have one per site. The 60 drive is made up of 800 GB SSDs and 52 10 terabyte drive. For those of you who are not familiar with E-Series, E-Series always come with two heads, controller A and controller B. So each controller head will have two iSCSI connections that the servers are going to be using to communicate with the E-Series. Also, there's a management interface that you use to manage your E-Series, and also there's the console that you can use to troubleshoot your E-Series in case you cannot get to the management interface. This is the physical connections that we have on our E-Series. So each controller head has two iSCSI connections, and it is through these connections that all the servers are going to be connecting to the volumes or the LANs that are created on the E-Series. For the management interface is used to manage your E-Series. So, and you manage the E-Series using the system manager. So whether you use the management interface of controller A or you use the one of controller B, they will take you to the system manager, which you can use to configure your E-Series or day-to-day administration of your E-Series. We also have the console connection. Like I said before, the console connection is mainly used when you have problems with the E-Series and you can't get to the management interface. Then you can connect to the E-Series through the console to resolve any issues that you are having with your E-Series. For the settings we have on the E-Series, we have configured alerts on our E-Series. Our alerts go in form of email to our storage operation, and also we have integrated our E-Series with Xenox. So what our E-Series does is that our E-Series will send a trap to Xenox, and Xenox will send those traps to our ServiceNow, and the ServiceNow will use the information contained in the data that is sent to it by Xenox to create a ticket for our storage operation. And we have also configured the syslog. So all our syslog is forwarded to the Splunk server. For this configuration also, we enabled what is called automatic load balancing. The automatic load balancing is a feature that provides automated I/O balancing, and it ensures that incoming I/O requests from the host is dynamically managed and balanced across both controllers. So when you have automatic load balancing enabled, it basically performs two functions. It will automatically monitor and balances your controller resource utilization. It will also automatically adjust your volume ownership when needed, thereby optimizing your I/O bandwidth between your host and the storage array. For access management, we are using the local database on the E-Series. You can also configure your E-Series with a directory service application like Active Directory, LDAP. But here we have chosen to use the local database to manage our E-Series. For the volume configuration, before you can create a volume on an E-Series, you need to create what is called a storage pool or a volume group. For this configuration, we created a storage group, and we created a storage pool. And a storage pool is a set of drives that are logically grouped. You can use a pool to create one or more volumes accessible to a host. So your host does not see the storage pool. What your host actually sees is the volume that you create on the storage pool. So here, if you look at the picture down here, we have created a storage pool with the 50 drives. And also, we created the cache with the 7 SSD drives. Basically, what the cache is for hot data that are accessed frequently. So any data that is accessed frequently is placed on the cache, so that when a host requests that data again, the data is not read from the hard drive. The data is read, from the SSD cache. How does the SSD cache work? When the CPU needs to process any read data, it will first of all check in the DRAM cache. If it does not find the data there, then it will check in the SSD cache. If it's not found in the SSD cache, then it will get the data from the hard drives. But if the data is deemed worthwhile to cache, then a copy to the SSD cache is sent, and that copy is going to be cached, so that the next time the host needs the data, the request is serviced from the cache. Also, this model of E-Series comes with what we call a workload template. So depending on the type of application that you want to use for your E-Series, you can use the workload template to configure your workload. A workload is a storage object that supports an application. The E-Series comes with different workload. You have the one for Microsoft Exchange, you have the one for Microsoft SQL, and everything we have done here, the 8 volumes we have created, everything we have configured here is from the Veeam workload that comes with this particular model of E-Series. Question time. I don't know if any of you have any question.
Oh, there is the chat. Let's check out the chat. Okay, so Elias says there's a VCS and SnapCenter is targeted to ONTAP systems only. There's no plans to support other platforms. HCI Solidifier has a VMware plugin also. Which read requests will benefit from the cache? I think that's for you, Victor.
Yeah,
Victor?
sorry, I was on. Yeah, sorry, I was on. I was on mute. Yeah, what it does is that any data that is accessed frequently, it has an intelligence in itself that it will use to determine all the data that are accessed frequently. It will mark them as hot data and it will place them in its cache.
Does that help, Mario? Okay. Which data will that be? What data gets read frequently? Victor, can you answer that?
Yeah, sorry, always, I don't know, always automatically go to mute. So what happens is that you are the user who is using the equipment. So if there's any particular data that you are accessing all the time, the E-Series has the intelligence to know that this particular data is being frequently accessed, being frequently read. So it will automatically place that particular one in its cache.
Well, we're down to 1 minute here left. Thank everyone for coming today. So as Elias first mentioned, we will send out a recording of this. We'll send out the presentations. I've captured we'll capture a transcript of the conversation, so you can see that in the notes sections of the presentation. And if you've missed it here, we have a couple of resources listed here at the end. This is how to submit a Veeam Support Case, and then some other reference materials, and that will be in the presentation as well. So thanks everyone for attending today. If you have any other follow-up questions, just reach out to Elias and he can pass them on to this team, and we'll be happy to provide you an answer. Okay, we hope
Thank you very much, everybody.
Yes, thank you.